tables and models that look something like this. And this is 23 different models. Now the key ones that we need to sort of be aware of are these two, because they're British. These are the Hadley Centre models from the Met Office in Exeter, and the one that is sort of the old one, HADSEM, has now been superseded by HADGEM. But the point about it is that if you look at this part of it, this tells you the differences in what the models do. So this, for instance, has a different spatial resolution, a different atmospheric resolution, a different scale, so the scale improves. As we can see, the ocean suddenly becomes much more smaller. The boxes in the ocean are much smaller. They're a fifth the size of the boxes used in this one. And then they make various assumptions about sea ice. But the crucial ones are the resolution and the nature of the way they actually define the atmosphere and define the ocean in particular. And to say the HADSEM is the official one. It's a full model of atmosphere and ocean circulation. And it's the one that's based for UKCP09. Now UKCP09 I mentioned I think last time. This is DEFRA using the HADSEM output, not the IPCC output. Interestingly, the UK government, or the DEFRA, decided that rather than sort of go for an average model of 21 models and let's take the middle range, what they said was, no, we've got a perfectly good model, HADSEM, it's British, therefore we will feed this one into our predictions at the regional scale for the UK. And the UK CP09 projections, which look at probability levels for winter, summer temperature change, these are values using 90% probability that it will be summer, will possibly be changing by this degree, a certain temperature, a certain date, etc. These form the basis for all local government and government office projections. So if you're going out to the Somerset levels as the Environment Agency head, and they say, have you got a plan? What's your strategy? They will say, right, well, our strategy is being driven by UK CP09. That's the official strategy, and we have to do our projections and our management strategies according to the projections and probabilities of change in UK CP09. So it is not an IPCC-driven change. It's not saying this is what the IPCC range of ensemble models suggests. It is actually focusing on one model and using that.
What for the HADSEM3? What is it? A high average, or like is it below average? Or?
No, the model is irrelevant. It's what you feed into it. So the probabilities are here according to different scenarios. So I've used this one. I can't remember what scenario they have run to get this particular. Yeah. So HADSEM will run with SRES B2, A1 and A1B, and they will say, right, according to that, using those scenarios, this is what we get in terms of temperature, using this particular model. So so the range, the probability is based on a probability density function of the different scenarios and different ranges that they've got. What's the highest probability according to the model using these scenarios of temperature change according to HADSEM model? I've put UK CP09, I think. It may not be on yours, it may be on issues in climate change reading. But you can access it up and you can see how it's done, you can see the thinking behind it. But that goes back, it's a political decision. Why use HADSEM? I mean, there's a temptation to say it's because it's British. There's a temptation to say that it is probably the best model. The Germans might disagree, the Japanese would disagree, the Americans would certainly, obviously disagree. There is an argument that if you're actually modelling from here and you want projections for here, even though you're doing it globally, perhaps the way you think about climate, the way you experience climate might have some impact. But it's a cultural decision, it's a political decision. And politically, you can see basically the government saying when Mucheln is flooded and you've got Charles and Camilla swimming across to take tea and biscuits to the people there, and the Environment Agency is being hammered and the government DEFRA is being hammered, and the Met Office says we need a new supercomputer at £20 to £5 million running costs per year, say, then again your voters can say, why on earth are we spending 25 million on a new computer for the Met Office? You say, well, actually the Met Office run not just the weather forecast, but they run the projections which we then use for planning, so it's all part of the planning process. So you can see a political argument for doing that. I mean, it is a very good model, obviously, but it's different from the other models. There are slight differences, and HAD-GEM, which is the one that takes over, is better. It is a better model. But UK CP09 could only be produced in 2009 based on the output of HAD-SEM. So one of the questions you would now ask is, does HAD-GEM come up with any changes in the projections which then should feed into the next UK CP 15 or whatever? And how often do you need to do that? So what we see with HAD-GEM is twice the vertical resolution, much better horizontal resolution, better sea ice effects, better clouds. Clouds are always going to be a problem and improve from model to model. And if you look at the difference in the output, which is really where we're sort of coming down to, the idea is that regionally, probably it will be not that much difference. But if you look at projected, one of the ways of testing your model is to run it for what it should be now, and where are the errors. And what you find is that these are running what sea surface temperatures should be using the model. You can see where the error terms are. There's fewer errors on this. In other words, it's a better representation, different representation. This gives this one a bit too cool, whereas we've reduced the Pacific problem, they've reduced the dark, but they've shifted it the other way. And if you look at the difference there, sea surface salinity projections, again, against reality, on that one you can see there's more of it is white. The whiter it is, in theory, the better, but you can see this one has shifted quite a lot in terms of temperature. Sometimes it's hotter, sometimes it's cooler. So there are improvements, but you might improve the model, but if you're projecting, you still don't know whether in fact it's a better model to project into the future. And if we look at the other models, the NCAR, just looking at these, first one's Beijing, so the Chinese, they must have lots and lots of little hamsters sort of running around on wheels, powering their computers. But you can see that it's a pretty good model. I mean, it's a very efficient model. Then why the Norwegians get in? The Norwegians get in because the BFNS Climate Centre is one of the oldest and best modelling centres in the world. And of course the Canadians and the French and the Germans, two lots of Germans, Max Planck and Bond, so separate ones. This is the one that comes out as the main American model, CCSM from NCAR, Atmospheric Research over in Colorado, developed at NCAR. It works in a different way as a model to the other models. I won't go into the details because I don't understand how these models work, but effectively they've got 4 units, as it were, atmosphere, sea ice, land and ocean, which they then combine through what they call a coupler. So effectively it divides the component parts into different components and then connects as a sort of exchange mechanism. So rather than sort of see it all as one big interconnected model, they mathematically separate it out and then bring it together through a coupling mechanism, which is not reality. The actual process of the modelling is not a mirror of the way the world works, probably, but it's an effective way to link mathematically and in computational terms the way things go. So it's a different way of structuring. They might have, broadly speaking, exactly the same way to treat the ocean as HAD-SEM or Potsdam or China. But the way they then link that with the other components is different mathematically. That has now improved from CCSM3 to CCSM4. A lot of new processors, don't worry about this, but huge range of detailed processors. Once you go into a box, you can do things like grain size dependent snow aging, the size of the crystals in snow, sub-mesoscale ocean mixing. I mean, huge detail But obviously the key is that you can improve those, but linking them to your other boxes is the key, whether in fact that is acceptable as a way of doing it. That is actually also where this is meant to be the most powerful model, the CC SEM, and the other thing about it, this was 2010, and it is actually freely available for anyone to use. So this is not commercially protected data. So you can log on, download all the source code, you can run it as much as you want. So if you fancy a bit of modelling, you can go in, download it, play about with the Earth system. I haven't tried it, I don't know how easy it is to do it as a sort of, obviously not run the whole model, but to get into it and use bits of the model. But it is open, and that's a very important element, because the whole issue about climate modelling is that commercially, projections are crucial. Because commercially, depending on the inverted commas accuracy of the projection, you can make a killing or you don't. Or you could lose money on it. If you commercially predict that sea level is going to rise by 30 centimetres, and you invest in insurance in a particular area, you could, and it happens to be 50 centimetres, you lose a lot of money. So, potentially there is commercially sensitive data, but these are actually open access. You can do it if you want. So, biases and inconsistencies, there are plenty between models, between model and data. Just quickly, I'm going to go into these in any detail. Some models over-predict. Some models always end up with the warmer end of the spectrum. They'll always give you temperatures in excess or will under-predict. And this regular systematic bias between different models. That is clearly obvious in certain of the models and certain the way the models run. So if you're a modeler, you know that, the Chinese their model always under-predicts the amount of sea ice loss or something like that. That's because the nature of the parameters used and the nature of the way the model is run. Within the model, season length is also an